Okay, then welcome to the second part of today's practicals. We can start the recording, and now we have Thomas here for the
Hello.
next example. And yeah, we will talk about now abstract classes. So this is more or less the continuation of what we've seen before regarding inheritance and polymorphism. So maybe you want to explain what we do now.
Maybe let's at first just take a short recap what abstract classes even are. If you remember, an abstract class is just a class that we cannot instantiate or create, but more importantly, we can inherit from it. To create sort of an abstract class, you can't really write abstract in front of it, but you just mark one method as virtual and then set it to 0. So just write equals 0, and then it's a pure virtual method, as it's called. Most importantly, all derived classes now absolutely must implement this method, but we'll come to that a bit later. So why even do abstract classes if you can't create them? You most commonly use them to group objects together that share an ancestor in some point. So maybe a parent class or a great parent class is this abstract class, and you want to group them all together somehow. For example, you can store multiple derived classes in one vector or one map, as you heard just before. Important to note is you can only store base class pointers, or you can only store subclass base class pointers, because you can't store the base class objects themselves, because as you remember, we can't create them, so they don't exist. Again, here it only works with pointers. So we've now stored them all in this vector, but how do we tell them apart? We only have this pointer, so we need another method to tell them apart. Intuitive and easy method sort of would be just an attribute in the class. It's great for simple values, just a name or an ID number or an enum, but you can't store larger functionality in it. It's really just a value, and you don't take advantage of the abstract class you just created, and we want to take advantage of that. Also before, you heard that we can use casts to differentiate base and subclasses. So casting would also be a method. Remember, it returns null pointer if it fails. So if it doesn't return null pointer, we really have the subclass we want. We can also access subclass specific functionality then. So it would be great in that use case. We also know exactly what type you're dealing with if you want to find out that. But it really becomes clunky to use. Imagine you have 8 classes that derive from one class. You have to create a switch which contains these 8 classes or an if-else statement, and this just blows up somehow. But it might not be necessary to cast all the time, because if you remember from before, we have the virtual method or pure virtual method in the abstract class. And as you remember, we must implement it, so why not use it for something? You can always call it without casting, and it would always go to the right subclass, because as you remember, the pure virtual method in the base class is 0, so there is really no method there. There's just, there's something there, but there's no code behind it. But still remember, you can't access subclass specific stuff. So if some subclass has some special method, it's not accessible through something like the base class object. You have to do more specific stuff then. But this was all very theoretical, and I believe it's best shown with an example. So I have prepared an example. We will implement a wardrobe, because if you're somewhat like me, you don't have a special wardrobe for pants and for shirts and for suits. So you have just one wardrobe where you store all your clothing. We might want to print all the clothing we have in there, or get the amount of pants we have in our wardrobe, or do laundry for all items at the same time. So let's do that and switch over to VS Code here. And the first thing we need is our abstract class, which in that case would be clothing. And as said before, we need some virtual method, pure virtual method to make it abstract. And in that case, everything, what you can do with every type of cloth is probably wash them. So we'll create a virtual method we'll call wash and set it to 0 like that. And
so basically this is the pure virtual method that you talked about.
Exactly. So there's a normal method would contain code here or at least something here, but it's set to 0. So basically only the existence of a method is known, but nothing more than that. And we also need some subclasses because if you go over here, we can now already create a wardrobe of clothing pointers like that. But if we want to store something in there, we'd have to do like wardrobe.pushback and then create a new clothing. But VS Code should already scream at us, object of abstract class is not allowed because of this pure virtual function. So we have to create something else there, and let's just do that.
And I mean, this also makes a lot of sense, right? Because when you have a clothing, then what is that? This is not
Exactly.
like something concrete where you know this is a pants, this is like whatever type of clothing. And in contrast, in the example before, we had the user and the admin user. And the user was something trackable. Yeah, you can create the user. A user can exist. The user can do certain things. The clothing is something like a template for something, which is not really you know it's the clothing, but what is it really? What type is it? So it doesn't make really sense to create a clothing, but it really made sense to create a basic user which has some low functionality.
Yeah, to use abstract classes most of the time, you will have some overarching concept or group and not something specific. For example, it would not really make sense to put maybe class suit here because a suit might be an object you'd want to actually have and you actually want to do something with. This really just kind of is used for grouping or maybe as a concept, but not really as an object you create. But let's continue on. It will become a lot more clear when we actually use it. So let's just create a shirt here, which we inherit from our clothing class. And as said before, we must implement the pure virtual function, so we'll implement it here, just like this, and also override it, just for safety. And maybe we want to do something in here, but let's for now just print out what is done here. Yeah.
Maybe washing skirt or something.
Washing shirt.
Shirt, sorry, yeah.
Would make sense here. So yeah, maybe to illustrate that there's really something different in all subclasses.
Yeah.
Semicolon.
Also at the shirt, yeah.
We create another class here called pants, which we also derive from clothing. And then just copy that from up there. And right here, washing pants. Over here, we actually need to create them. So we create them using just new, because we, as we said before, need the pointers here, and doing something on the heap makes sense in that case. And also push back new pants. And then let's here create a method that says that is called do laundry and just do laundry for a whole wardrobe. So in the function arguments, we just pass our wardrobe here. And in here, we can really loop over all, and I write here explicitly clothing pointers to remember those are really just clothing pointers in there, not the subclass or anything like that. And just item and the wardrobe. And just for every item, we'll call our wash method, which should work. Of course, in this example, we'll just ignore any kind of specifiers like private and protected, because I believe it's clear by now how they work, and it's a lot easier for an example if we just all create them as public. As you've seen here, if I do not specify anything here, they are private and I can't access them in the program here.
Okay, so now we've created our shirt and pants, which should hopefully work because they are like concrete objects.
It should work, so let's compile this and
one more time.
Semicolon. And if we compile them here, seems to have worked. And we should
call also the function do laundry.
Makes sense if to call it, and also pass our wardrobe in here. And if we compile it and run it again, we really get that it's washing our shirt and it's washing our pants without ever knowing if those were a shirt or a pants. It just automatically knows it has to call this function or this function because it can't really call this function.
So basically what we've seen before for the user and admin user, there it kind of checked whether the user is actually an admin user, and if it was so, it called the method on the admin user. Now it says, okay, yeah, it's a clothing, and now it also checks, or is it really a shirt or is it now a pants? So it can also differentiate between several subclasses here. And this is really cool. Yeah, so we do not know what type of clothing we have.
And we don't really have to know because we'll just take them all, throwing into the washing machine, and don't care what we put in there. We just wash it. But now we might want to do something more involved, and for that we use casting. And for this, we'll create another class, and that we'll call jeans. Jeans is a specific type of pants because it's just a specific type of pants. So we'll create it as that and then just implement the stuff from above again. And right here, washing jeans.
Probably this is new to you now. So we can also derive a derived class again. So now the jeans is a pants, and pants are clothings. So also the jeans is a clothing, but the jeans is also a pants. So really we can have multiple derived classes here.
Yeah, you can really just create huge trees basically of stuff that derive from each other. If someone here knows Java, in Java everything is just an object and it just derives from down there. So you can create large hierarchies and they're all clothing in the end. So back here in our wardrobe, we can also put in, because we went shopping and we bought some new jeans for ourselves. And maybe because we were really generous, we bought 2 jeans. And VS Code as of now doesn't complain. So this must work. But now we've bought so many pants, we want to know how many we actually have. And for that, we'll create a new method. And this returns an int, and we just call it get pants amount, for example, and pass in our wardrobe again. And in here, we'll take this for loop from above again and delete it from here and use the cast shown before. So if we dynamic cast to just the pants pointer here, the item we currently have, and if this isn't a null pointer, we'll increase some amount. So we specify an amount up here, And if this is some valid pointer, we'll just increase the amount by 1. And in the end, return the amount. And I believe this should work. So if we write get pants amount here and pass our wardrobe again.
Yeah, maybe you need to print it as well somewhere.
Of course. If we print it, we have pants. Another.
So maybe before you run it now, so we have created now the shirt, pants, and 2 jeans. And do this method here. How many pants do we have? What do you think? Is it 1 pant, 2, 3, 4?
I've seen a lot of hands for free, and this is good intuition because it's free. And that's because those jeans are a subclass of pants and will just cast to pants here. And as we had before, subclasses can be casted into base class pointers. And so it just counts everything that can be cast into pants, and jeans can do that. So they're counted as pants. So you can really just create subgroups of things using that and then only do stuff on them if you have a more involved class hierarchy in the end. But now, what we haven't used yet is the attribute maybe from before, and for that we'll need to create one also in the base class, and it would be somehow nice to show what's in the wardrobe, because if you maybe don't see that code, you would have no idea what's in there. So we'll create a name here. And we'll somehow need to set that name. We'll just use the constructor here. And for every constructor, we tell it name equals, in that case, it's just a shirt. So we just call it shirt. You see here, this is another way of setting the arguments in this base class, because using the constructor wouldn't really work here because this can't be constructed. So we'll just do it that way because name is also a member of this class. It's just not declared here because it's from the base class. So we'll also create that for all of those.
So basically we're now a bit lazy that we directly write it here instead of doing it like we have seen it before in the inheritance example, because it should not be the focus here.
Yes, and it's just this small example here. If you continue to use this in some large things, you have a large code part of the constructor, and the initializer list is probably in most cases a lot shorter, but we just have a small toy example here, and the focus is really this attribute. So if we create another function here called print wardrobe, and we'll give it the wardrobe again, where the arguments, and in here we use this same for loop again, but this time we don't want to cast anything, we just want to print what's in the wardrobe. So let's first just state in our wardrobe R, and then we'll, for every item, we'll print here. Let's indent it a bit so it looks nicer in the end. And for every item, we print its name.
Now, assuming there is some getter and so on, but we don't do this
Of
now.
course, this just uses all public here, which for large things, it gets really complicated. You might not want to get something from there directly, because in some cases it might be unsafe or you're unsure what you've written in there, or maybe a getter might do some specific thing. Maybe you provide a getter that already creates a dash in front or prettifies something, does some other logic. But for this small example, this would suffice. So we'll just create another end line in here so it looks a bit prettier. And down here, we'll print a wardrobe. And hopefully I have not forgotten a semicolon again. And it prints everything we have in our wardrobe, the shirt, the pants, the jeans, all with the names we gave them. And we have casted nothing. This code is really small. And it just works because every one of them also inherit this name here. And we just need to set it here. We could also explicitly set it from outside if you wanted to. But yeah.
So basically, we saw like 3 methods now to access the type. So the which derived class it is. So if you maybe scroll up again in the CPP file, so at the very start in the do laundry.
Yeah.
Here we call like item wash, and it's printed depending on the item type. So we printed the text, for example, washing shirt. So we know, okay, we have a shirt. We could, of course, return here string shirt or some identifier here.
Anything could happen there. You could also go into the class definition, into this wash function, and do in here something specific. For example, do maybe some washing instruction for all those types, but for just one specific type, maybe only shirts, you wash somewhere else or do something else, and you don't need to concern yourself out there to differentiate them first, but really only do this in the classes, so you only have to write small bits of code and not do large distinctions here, because if you wanted to distinguish here, for example, we'd have to distinguish jeans from pants, and then pants from shirts, and it would get really large, but this remains compact and pretty much easier to use.
Yeah, and yeah, these were basically the 3.
These were the
types that
the 3 things I wanted to show you. You will most likely need them in the future quite a lot, so maybe try this out on your own.
Then,
are there any more questions regarding that topic?
Probably. At least I hope that some of you already implemented something like this in assignment 1, because there is also an abstract class waiting for you. So, okay. I think this was also from your side, right?
This was everything from my side.
Then thanks a lot for the presentation.
Thank you for letting me talk here.
And we will continue now with the UML diagrams, but we first need to set up everything again. I hope that it starts to work. Okay, here we are, and now one and large. Yeah, and here we are. Okay.
Yeah,
UML diagrams.
Let's continue with UML diagrams. So I think you've already seen them in the lecture, and also very briefly for inheritance, but we want to talk a bit more about inheritance now with UML diagrams. So as you've seen, these UML diagrams just show the relations between classes, and you have already seen in the lecture how you present such a has a relation, such a composition. So that some class has a member variable for some other class. And now you will see inheritance, which is this is-a relation we talked about today a lot. And these are just different kinds of errors we'll use in the UML diagram. We can also represent public and private attributes of these classes and data types. We have an example which you'll draw on the blackboard with some very similar description as you will get for homework 2. Your homework 2 description will be a bit longer, but the key takeaway is so how we describe these things, and also it will be typesetted the same way, so you can exactly see that classes or words with the C in front and that are uppercase, these are the classes you have to actually represent in the UML diagram. Anything else, you don't need one extra box, so to say, in your UML diagram.
So I try to draw this now on the board. For those who watch the recording, just go 5 minutes in advance, and then we will also show a picture which is hopefully similar to what I have done.
Yeah. Don't worry, if you watch a recording, you'll see it later.
Okay, so what does it state at the beginning?
Okay, so first we have this UML diagram describes a dog.
Okay.
And this dog is a class.
Okay, so maybe we have a dog, and I would just indicate it with a C here, which you don't need to do in the homework. Okay.
Then maybe let's just skip a bit forward. We also see we have an animal.
Okay, so we have an animal. Maybe do it here.
So maybe first write down all the classes we have.
And I will indicate it with an A here, but also a C would be fine, because it's also a class, but just for distinction for an abstract class. Okay.
And we also have a leg.
Okay, we have also leg. And this is also a class, right? Okay. Maybe do it like this. Okay.
And now we have a dog is an animal.
Okay. So a dog is an animal. So we make now a large arrow here because the dog is an animal.
Yeah.
So this is the, maybe I write it also here, the is-a relation.
So this is different to what you've seen in the lecture. This now has this pointed tip of the arrow, which indicates that we have inheritance here. If we continue, we see that all animals have a private name and a public method eat.
Okay, so we have a private name. Private was a minus, so this is not visible to the outside. So this is the name. And we have a public, so this is indicated with a plus, function eat. Okay.
Yeah, and what you need to do with the homework is always indicate the types of your attributes of your classes.
Oh, I didn't do that. Maybe the name is a string.
Yeah.
And have to do something for the eat method? I don't think so.
No.
Just for the attributes. Okay.
Then, additionally, the dog has a private fur color.
Okay, so the dog has a private fur color. And
so color here does not have the C in front. So we do not need to create an extra box and represent this class separately. We can just make up some type.
Maybe, I don't know, is an enum color. But you could also store it in a string, for example. It really doesn't matter.
The dog also has 4 legs.
Okay, 4 legs. So they should also be private. And maybe we store them in a vector. So legs, maybe in a vector of type leg. And now we need to think about that the dog, and so basically we have here now the leg class.
Yeah.
And now the dog has an attribute legs. So this indicates here now a relationship.
We can also see this because here again with 4 legs, we see that we have here the symbol which actually means we need to represent this in our UML diagram.
So we also need to draw something here. And we do this in this way. So this is not an arrow anymore, but this is now some symbol for composition here, because the leg is part of the dog, but it's not that the dog is a leg. So this is just a has a relationship.
Yeah, and then we have a public method which allows the dog to bark.
Okay, so barking.
Now the leg has a private length and a public method that implements walking.
So it has a length. Maybe this could be an integer, and the public method walking. And I think that's it, right?
Yeah, that's it.
So let me close them. So, and this would be the description of our 3 classes with private and public attributes and methods, and the relationships is and has a. So the important thing here is also that, I mean, the dog does not just has one leg, but it has multiple legs. But for us now, it's just important that it has some legs, so we do not distinguish here like whether a dog has many legs or some count here.
But for example, you could also write over the arrow to leg has 4 or has many. That's also fine.
Okay. We might continue now. Now the question is how you can draw them.
We really recommend that you do this somehow digitally. I mean, you can draw it by hand. That's fine for the homework, but we need to be able to actually read your diagram. So you actually need to draw this in a nice way. And if you have many classes, it can become, and if you just order them randomly somehow on your sheet of paper, then it can become pretty, then the arrows could be all over the place. So maybe it is a better idea to create them digitally so you can move them around afterwards. And you could use Draw.io or diagrams.net. We won't be showing this now. It could be that you already use this. But there's also something called Blend UML, where you can just specify with text how your UML diagram should look like. And then render this to an image or PDF.
Yeah, so maybe open the editor.
Yeah, there's also the Git repository of Blend UML, but there also exist online editors. I just searched the first one that came up here. And as you can see here you can
They made it a bit larger.
Type something. Yeah. I also prepared the previous example. I'll just copy it over and then explain it here. So maybe first save and preview. And we can see that you did pretty well.
At least I hope so, yeah.
Yeah. The difference here is that they use this square symbol for private and this round symbol for public. This is also fine if you do this for your homework. It just has to be different for private and public members. You have, pretty much a large creative freedom of how you want to design your UML diagram. It just has to contain some central elements which we describe in the homework description. I think very detailed what it needs to implement. So let's actually look at what we have here. We always have, well, the start and end, but okay. Then we have here this abstract animal. Here we can actually say that this is abstract and not a class. What this does is that it creates this A here instead of the C, as you did on the blackboard. Then, pretty straightforward, we specify the class, a colon. So we say, okay, the animal has a private name with this minus, and then we write another colon and can just write a type. And then with this plus here, with the eat method, we can specify a public, something that's public. Yeah, I now also specify types here, what the function returns. You can also do that. Then, if we have this dog here, we can just write class, but I think it's pretty similar. Actually, you just write again dog, the name, and then the type. Yeah. And what you write back here is, you can write anything back here, so it does not, yeah, so you can do like something like vector and specify the type here of leg, or you can also do something like, you can just write something like this. I don't know if you need, yeah. So you can do anything you want, it just has to be clear that this is a vector or a list or an array of some kind. And yeah, then let's come to the relations. Also pretty straightforward. This arrow indicates inheritance, as it does with our drawing. So yeah, and then with this star, this indicates composition. So this is this diamond symbol here. And I think this is pretty nice to work with because it automatically places your classes in a nice way, so you don't have to move them around or draw arrows by hand.
So what is the connection to homework 2 then? Yeah, you create an UML diagram in homework 2. Yeah, please use some of the tools, don't do it by hand. I think it's easier to read for us and probably faster for you.
Yeah, if you really draw it by hand, you probably need to draw it 2 times if you want to have it readable. Because when you draw it the first time, then yeah, you somehow need then to move them around so that the arrows don't overlap and it gets really messy.
Deadline is in 2 weeks on a Wednesday. And yeah, we released the homework already today so that you can start now if you like and don't need to work in the Easter break. But you can, of course, continue with assignment 1 first and then do it afterwards in the Easter break. So you just have 2 weeks instead of 1 week. So it's just something which is hopefully better for you. And submission is in the Teach Center. You just upload a PDF that contains your drawing. And why do we have this homework? This is kind of a preparation for assignment 2, because in assignment 2 you will need to code a larger project, and one of the first steps will be that you create a UML diagram of all the classes that you will need in this assignment. And so use this as a chance to train creating a UML diagram, and then in the assignment 2 you will have to use this as well. Any questions? You can view the description in 1 hour, exactly 1 hour.
It's very similar to the one we had before, and it details everything you need to implement.
But a bit longer than before.
Yeah. So I think it will be 18 classes or something.
Yeah. Okay. So we talked about assignment 2 a little bit now, and now we talk about the command pattern in the last 30 minutes, hopefully. This is also something which you should consider, at least for assignment 2. And this is now a new method how you can construct the processing of commands. So I hope some of you did assignment 1 or had a look on it. Also their commands were used in this zoo simulation, where you did something with the animals and the enclosures. And now we show you a different method to do this. Should I do the motivation? Yeah. Okay. So basically how to do this, already told this. And what we assume is that we have some central game class. So in assignment 1, this would be the zoo. Or if you think about some game, maybe where you can move persons around, where you can interact, and I don't know, maybe a card game. Yeah, let's keep it with a card game. So you have a card game, and then one command could be place some certain card, or one command would be show your draw a card, for example, and so on and so forth. And this is modeled in some large game class that handles some of these functionalities here. And what could be a first approach, and this is similar to assignment 1, there we also have a class command line and a class command. So these are the two classes here for the commands. And basically the command class has two attributes. One attribute is the type of the command, for example, to draw a card, or for example, to play a card. And the other attribute would be, for example, a vector or a list of parameters. So if we want to play a card, maybe we want to specify that we want to play the 5th card in our hands. So a command would be play 5, and then the attribute type, one attribute would be the type, so play, and the other would contain 5 as a parameter to know which card we want to play. And basically, we deal with this command object. So we read in a string from the user, then we check, is this a valid command? Are the parameters valid? And so on and so forth. And at the very end, if this is valid, we say, okay, this is your command object. This contains the type, the parameters, and this is then taken and returned from, in this case, the command line class. And based on this command, then the game class can execute some logic. So then the game class says, okay, draw, play 5. Okay, I go to the correct player. I see, has the player 5 cards? And if yes, I play the corresponding card.
Yeah.
So basically, this is what you implement in the zoo simulation, where the zoo gets a command, and then you check what should be done, and then do the proper action on it.
Okay, but now we just learned about abstract classes and polymorphism, and maybe we can use this somehow to aid us passing commands. And sorry, you still have this visualization.
Sorry, it's still my part. Yeah. Visualization of that: the game goes to the command line reads the command, parses it, returns the command. The game executes the logic.
Yeah.
I also have one more slide for that. Sorry. It's really lengthy. Maybe do it very briefly. So the advantage is, that's also why we use it in A1. It's very basic, the concept. And once you have implemented the command parsing, as we provide you for assignment 1, you just have to kind of check the type of the command that you received in the game class and execute the correct thing. But maybe if you have implemented this already, you need to distinguish all command types. So you need to write, if the command is this type, then do that. If the command is this type, then do that. Or make a switch case. Switch command type, this case. So you really have to distinguish in the game class all the commands. And this is a bit annoying maybe. And also this command logic of deciding which command is there needs to be implemented in the game class. We talked about this. Now, what is better?
Yeah, okay. So, as I said, we've seen about polymorphism now. Can we use that to actually help us with passing commands? And well, I propose a second approach where we create a command parser as before, but we make the command an abstract class, and then for each command implement one subclass and use this instead of the switch to distinguish between different commands.
So the command is the clothing, and the move command is the jeans, and the help command is the shirt, for example.
Yeah, okay, we said that. And this would look something like this. The game registers some commands with the parser, then sends the input to the command parser. This command parser somehow looks up the correct command, and then when it has the move command, it calls some virtual method on this command which actually implements the logic, and then this move command has to somehow communicate with the game class to move the player.
So, like the large difference is now that not we go to the command parser gives us back the command, and the game does everything. But now really we go to the command parser, then it parses and takes a command, so the right command, and inside of this command the logic is implemented. And if we do this nicely, we do not need to implement these large switch cases.
Okay, yeah, then let's continue with the example. We will implement this now. We already prepared something. We have this command parser class.
Yeah, maybe we start with the main. Yeah, we have in the main the game class already. And do we have already something in the game class? I think so.
Yeah. We just have this game class, which somehow gives you the player count. And there's also this start game method, which is called in the main.
So basically this is already done. So we create the game, we call the start game method, and then this print is done here. Okay.
Okay, then we have this command parser here, which we did not implement yet, but we will. And I think we prepared something for the command. Yeah, we just prepared a class for the command. So nothing much yet. What we want to do is, when we start the game, we somehow want to, maybe we can also do this as an attribute here. To have some command parser in this game class. And then down here, when we start the game, we want to actually register all of our commands with this command parser. So just for overview, what we want to do is register some command. And for example, this now could be some help command we'll implement or something. So this is what we want to do. Let's start with actually implementing some command, or maybe, no, let's start with the command parser first.
Okay, so the object that should be responsible of creating the correct command.
We said that this will be our abstract command class. We actually did not implement any subclasses yet, but we'll do this later because we will need to think about what these subclasses need to do. But for now, in this command parser, we'll just create a map, as you've seen today, which maps from a string, which will be the name you type on the command line, to some command pointer, which we'll be able to access. So here we'll place all of our commands, and this is a command pointer so that we can use polymorphism and then call the correct function of this command. I don't think we need any constructor. Let's just...
So we write now the register command method here.
Yeah, and this will take a command pointer. And not only command pointer, but also a string for how this command is named. I forgot this here.
So we also give the string that the user should enter here, basically.
Yeah, so this is what the user should enter in the command line, and then this command should be executed. I'll implement this in the CPP file. Okay, and what we want to do, we've seen this today. There is this emplace function where we just pass in the name and the command. So nothing really fancy yet.
So basically we just insert the commands into the map.
So okay, we did this now. We registered a command. Now this command parser should also help us execute commands. So we want to do something like execute, and then we'll pass in the input. So for example, this is what the user entered. So for example, the user entered help.
So this is maybe we can just chat with a single standard get line that we can actually type it. Maybe make an input string. Then we call getLine, which we have seen 2 weeks ago. Store it in the input. Store it from the in. Just the in, I think.
Oh, okay. Yeah, right. That's the type. And in the input.
Okay, and then we execute the input. So the parser gets also to see the input.
Yeah, let's implement that. So this execute function here, which just gets the input. So what do we want to do here? Well, we want to find the correct command which is stored in our map now. So first, maybe split input for parameters. If you want to have parameters, but we'll leave this out now. You can handle this here then. And then once we have basically the command we can execute, so the first word that was entered in the command line, then what we want to do is we want to find the right command. So we'll call add, something like this. Maybe I could even, let's do something like, so we pass this command name out of this input, and we also pass out the arguments.
So we assume that this would be done now, but we don't do this here because.
So we somehow split the arguments and the input, and then we'll get the correct command which of this name.
Okay, so we call commands add command name. So this is a map. So we go into the map with a string and search for the corresponding key in the map.
Yeah.
And when we see this key, we take the value, which is then a command pointer as we specified, and this command pointer is returned from the add method. Okay.
Something for you to do. And now, what do we want to do now? Well, we somehow want to execute this command. So we'll probably also implement an execute method for the command and pass the arguments there. So, but now this command has no member execute. Well, we'll need to implement this. In our command, we'll make this function execute, which takes a vector of strings, which will be our arguments. I mean, I can name this here, and we'll make this a pure virtual function, because our command is something we do not want to instantiate. We do not want to create a command object, because what is a command? We don't know. We just know what a help command is, but not what a command is, and we need this virtual here. Okay, and if we now create the help command, like this, and then implement the execute.
With the arguments.
Yeah, we don't need arguments, but okay, I can write the name here. Then I'll implement this in the CPP file. Like this. You don't need to override here. And then in here, and no,
So here we really implement the command.
The logic of the command, yeah.
Okay, so this prints then the help message as it's the help command. Okay.
Okay, this command parser now seems to work, and now in the game we can also create this help command. And of course, at the end, we need to delete all commands again.
Yeah, but it's probably not so important. Maybe we just look again what we did now, because these were like 3 classes and all acting simultaneously here. Maybe this is a bit too much if you see it just once. So what we do is we have this command parser and we register a command to it, namely this help command here. Okay, so we have this help command here, which is registered to the command parser. Okay, what does the command parser do with it? The command parser simply stores it in the map. So in the map, we have then the key value pair where help is associated with the help command. Then we could do this now for multiple commands. Yeah? Not just for the help command, but also for a move command or for a play command or whatever. So this is done first and once. And then we read in some input from the user later on, whenever we are allowed to fill in commands. And then we just take the command parser and call execute on the input. So we just don't provide anything else, just the input that the user entered. And then the command parser says, okay, I go in the execute method, I do something with the input, for example, split it in the command type and into arguments. Then I know the type string that the user entered, for example, help. I go to my map and call the add method on it. So I get the corresponding command, if it exists, provided it exists. And then the only thing that is left, I just call execute on the command. And the command then does the right thing. And in this case, the command, as we see here, this should be help command.
Yeah.
So the help command, when it gets executed, it prints the help message. Yeah, or another command would now draw a card. Okay.
Yeah, so let's compile this. Execute this. Okay, we can now input something. We did not print anything, but let's first try something.
It probably will not work, but let's try.
And yeah, we get now this exception because we know, okay, the command parser does not find this.
Maybe we can see also here it states map add. So this specific phrase is not stored in our map, so it's not associated with a command. So it also cannot be executed.
But if we try help now, then actually our command is executed. So if you write the program now, you would probably to catch this error here, but this is something for next week. Or you could check before calling add here if with, I guess you could do that. We could do something like if command contains command name.
And only then execute it. Yeah, this is nice.
Something like this. And if we do not have it,
we print some error message, for example. Yeah, okay.
And I think
you need to compile with C++20, then it should work.
Yeah. And if we input something wrong now, then command not found.
Okay.
Okay, then, now we actually want a command that does something in our game. And what do we have in the game? Well, we have this print player count method. We want to call that. So what we'll do now is create a new command and something like count player command. We'll also derive this from command. implement the execute. So this in the command.cpp, semicolon.
You're making the same errors. This
is now the count player command, execute. Okay, but here we somehow need to access the game, but we do not have it.
So because you want to call this count player
Yeah, I want to call
method.
this count player method, but I do not have this command here. So, well, what could I do? Well, I could, for example, save a game reference here, and because we create this command in the game, I can just get this game reference in the constructor. No, sorry.
This, yeah, in the count player command. So we just pass the game to the command such that the command knows about the game.
Mm-hmm. Yeah.
Maybe call the constructor of the command first. No?
Mm-hmm. Call the constructor.
In the game HPP.
In the game HPP.
Yeah.
We need to register this command here.
So whenever we add the command, we need to register it first.
For example, just with count.
Mm-hmm.
And then new, I think, count player command. And then we need to pass the reference to the current class. And I think you did not do this, how we get now the current game here. There's something here in C++, this is called this. And this is just a pointer to the class which we are currently executing. You might know this from other languages. I don't think this is too hard to understand. So this is just the game we are executing start game on right now.
So basically, in the main, we created this game object, call start game. Then this is just the address of this object here.
Yeah, or the object which we called start game on.
Yeah.
So now that we know how to access this, we can just dereference this to get the reference from a pointer and pass it to the count player command. We still see some errors here. And I think if we try to compile it, it won't work.
Mm-hmm.
Yeah, because it does not know game. Okay, let's try to include this. Maybe this will work. Okay, no, it does not. Let's look at the errors.
Yeah.
This is the last one we executed, right? Yeah.
So this is now really ugly.
This is a bit confusing because it somehow doesn't know what a command is, even though we had that. It doesn't know what a command parser is. It doesn't know what the game is or the count player command.
So it doesn't know anything, right?
Yeah. So what's happened here, what we did here, this is something you could encounter when implementing this. Let's look at it. In the command HPP, we included game. In the game, we included command. And this is a loop now. So we start here, okay, command HPP is not defined, we include game. Okay, game is not defined, we include command. Then it's already defined, so we do nothing here. And then we continue here, but we do not know here then what the command is. Because this was never reached. Because when we included game, we included command. This is not executed. The game here, so the compiler wants to compile this, but here it doesn't know what a command is because we didn't reach it yet.
So kind of they depend on each other and one needs the other and otherwise we cannot do anything.
Yeah. What you need to do here now is to forward declare that this class game exists.
And this basically means now, trust me, there is some game. We don't know how this is implemented. We do not know anything about it, but there is a game. This is good enough for now. But of course, we then don't know what the game is. So it probably should not be possible to have a reference on it. But we will see, yeah?
Oh, okay, we'll see.
We will see. Maybe compile it, by the way.
No, it works.
Okay, this is surprising. Okay, so
yeah, but I mean, the reference does not need to know how big the game is.
Okay, so we can use the game reference here. If we say compiler, there is the game, then it's fine.
Yeah, here we say we just take some reference to something called a game, but we do not know what it is. But in the CPP file, here we can include the game, because as we have looked at this loop before with these classes, the CPP file never appeared in this loop. So this is completely fine. And then here we can access the game and call the print player count.
So now the reference to the game is stored in the command, and over this reference, the command can execute something in the game or can communicate to the game.
Yeah, with the example on the slides, for example, with the move command, the command could first retrieve the playing field from the game, do many checks, and then set the position of the player in the game to the correct one, for example. Let's try to compile it and let's see if this works. Help. Okay, this still works. Then I call it count. And yeah, this also works. So if we look back into the game, we can see that this is a pretty simple setup where we can easily add new commands. We just need to derive from this command here and then register this command, and then it automatically works. And you do not need to do anything else. You do not need to change any switch statements. Yeah.
So this is really nice because there's literally no switch on the command type at no point.
Yeah. So if with the previous approach that we did with assignment 1, we wanted to add a command, we would need to add an enum type and then change a switch statement. And maybe if we have multiple switch statements, we need at every point where we switch over the command type, add this command. Maybe you also did this in ESB. But with this polymorphism here, we do not need to do that. We just need to register the command and create the class where we implement the logic. And it's also really nice because we now have this separation that in the logic of each command is in a separate class and not everything is in the game class.
Yeah, and if we add now a command, just implement it, register it, and execute it. But execution is already automated because once it's stored in the map in the command parser, yeah, everything is done for us already.
Yeah.
I think this is everything that we have here on the slide. Maybe.
You want to skip this?
No, go through it, but I think we have seen everything.
Yeah, so we explained the advantages. So extensible, adding new commands is easy. We do not need switch statements. Maybe some disadvantages, as we have seen. Passing this reference to the game is a little bit awkward, and we have the game passes the reference somehow. So it goes from the game to the command parser to a specific command, and then the specific command calls again some methods on the game. So this somehow is also a little bit more complicated.
Maybe switch to the code for one last idea on that. So, I mean, we learned kind of here in object-oriented programming that every logic related to a certain class should be implemented in this class. So everything related to the game probably should be implemented in the game. So as we can see, print player count. Yeah, so this should be kind of implemented in the game because this is something which is related to the game. And it might be a bit awkward that we now have another class, so the command class, which now do something here. And now it's fine because it interacts with the game and say, okay, yeah, give me the player count. That if we implement here larger logic, then maybe this logic is related to the game, maybe strongly related to the game, for example, to move a player on some playing field, but it's not implemented in the game. And this can be a bit awkward maybe, but on the other hand, it helps you that not everything is written in one class. So this is then spread around multiple commands, and maybe.
You have an easier overview.
Yeah.
And if you do this for your, A2, then you probably should implement as much as you can in this execute function and as little as possible in the game, or just some abstract stuff in the game. It's just some getters and setters type of functions, and do as much logic as possible in the actual command execute functions.
Okay. So it was really nice because now we also demonstrated the map and the abstract classes.
polymorphism.
Yeah. Okay. And now we're nearly at the end. Just to summarize what we have seen. So we saw really a lot about inheritance, polymorphism, and abstract classes today. We talked about the map, UML and homework 2, and now the command pattern. Yeah, which fit very nice into the time, and you should consider it for assignment 2. It's really nice. Okay, last question for today. Do you have any questions? Yeah?
One question. If we declare the variable game declare class game inside of main instead of the command product, will the linker be able to see it?
So you mean that we implement or declare the game directly in the main.cpp?
Yes, will the linker be able to see it?
If you do it before you include anything else, then probably if the main is compiled first. But if some other CPP file is compiled first that then includes this header, then you have again a problem.
So what would not be possible if you have the game here declared in the main CPP, then you can never include the game in this command CPP and call the game on it or
You can
get access
include
to the game.
but you cannot include some other header which uses the game, right? Or does this
So your
work?
question was, what if the class game is in main CPP declared directly? Yeah, then we can never include the game somewhere else, because then we would need to include the CPP file somewhere.
No, I think it just means that we do this class game in the main, but still have this game header with the
You
class.
come to us later on, and I think it's like 2.5 hours now. We probably should stop before we tell something stupid now. Thanks a lot, and maybe you come later on if you want to re-ask. Thank you.